So next up, we have Laura McGregor. This is a sponsored talk by Marks, so a big thank you to Marks. Laura has a background in analytical forensic science, a PhD from the University of Strathclyde, focused on chemical fingerprinting of environmental contamination using GC-GCMS. She currently oversees marketing activities across a full product range at Sepsolve, with a particular focus on GC-GC. I'll be talking about novel strategies for biomarker discovery. Thanks, Laura. Over to you.
Hello everyone, thank you for tuning into this presentation. My name is Laura McGregor and I'm the Product Marketing Manager at Sepsolve Analytical. And today I'd like to introduce our untargeted workflows for biomarker discovery and some new software that can help to transform the complex chromatographic data into meaningful results. So who are Sepsolve Analytical? Well, we're an instrument and solutions provider who are part of the Schoenberg Analytics Group alongside Marks International. And while Marks are known for their sample introduction techniques, Sepsolve are more concerned with the separation, detection and data analysis aspects. But we do work closely and often utilise Marks TD or Sentry systems in our solutions, as you'll see later. I'm sure many of you will already be familiar with Marks International, as thermodesorption is known as the gold standard in breath analysis. But I'd just like to take a quick look at each stage of the breath analysis cycle to show what TD can offer in terms of sample security and confidence. First, the sample tubes are checked and prepared for sending to the clinic. They're conditioned to ensure that they're blank, and blank tubes can be run to confirm cleanliness. At this stage, internal standard can even be added automatically for additional quality control checks before the tubes are capped and packed for shipment to the clinic. On arrival, a sample of room air can be taken for background measurement prior to taking patient breath samples and logging both of these before recapping and shipping back to the lab. At the lab, sample analysis can then begin. Dry purge can be used to remove water, and samples can be stored securely prior to analysis. When ready, calibration or QC standards can be run to enable quantitation and check system performance. Then samples can be analysed in an automated sequence by TD-GCMS, with stringent leak testing, as well as the ability to automatically add internal standard and options to recollect the sample split for archiving. And this process can be repeated hundreds of times reusing the same tubes. But what if we want to look beyond breath samples to other biological fluids, skin volatiles, or even for quality control of medical devices? So at Sepsolve, to tackle these additional sample types, we can use the Sentry platform for automated, unattended analysis of liquids, solids, and semi-solids, using techniques like high-capacity sorptive extraction, headspace, SPEMI, as well as automated analysis of up to 50 TD tubes. And just like with the automated thermodesorption units, at the heart of this approach is the electrically cooled focusing trap, which transfers analytes to the GCMS in a narrow band for optimal chromatography. It enables optional recollection of split flow for all modes, so you can have repeat analysis without repeat sampling. And it also means that samples can be enriched on the trap prior to sending analytes to the GCMS for improved detection limits. Next, we provide enhanced separation by GC-GC using Insight flow modulation. Here, two columns of different selectivity are connected to pull apart complex samples and provide greater insight into sample composition. And finally, we couple this with benchtop time-of-flight mass spectrometers for confident screening of the entire sample. So this approach allows us to get more information than ever before on sample composition. But the remaining challenge is, what do we then do with all of this data? And this is a problem that's seen across many untargeted discovery workflows, because you obviously don't know what's important or what to look for, and you can't just rely on the high loading compounds, as sometimes it's a trace peak that can be the biggest difference between sample classes. And finally, you really don't want to go to the hassle of identifying and quantifying hundreds of peaks when they aren't actually significant. So what I'd like to discuss in the remainder of this presentation is the chemometric workflows that we can offer in the new platform Chrome Compare Plus. to tackle untargeted data analysis for both 1D and 2D GC. So Chrome Compare Plus can import data in a variety of ways, as you can see here, but the one I'd like to focus on in this presentation is the untargeted raw data approach. Once the data has been imported, Chrome Compare Plus then discovers the significant features and can be used to visualize trends and create class prediction models to report future samples. So let's take a look at the untargeted approach in more detail. First, the chromatograms are aligned and then split into small sections or windows. And while I'm showing the 1D version here, this can be done for GC/GC data as well. Every MZ channel for every section is then compared across all of the samples, meaning that we make use of all of the raw data and reduce the risk of missing important details. Feature discovery is then used to highlight the most significant differences between sample classes, allowing these differences to be investigated and identified. And as you can imagine, when we're using this raw data approach and splitting the chromatogram into small sections, it's essential that your data is well aligned. So we provide alignment of the raw data in Chrome Compare Plus, and you can see quite clearly the effect that this has. After running the alignment, you're going to be much more confident that true significant differences are being found, rather than false hits because of drift. And it isn't just for 1D data, this can be run on GC/GC data as well. So let's see some results. Here we have a small study looking at 8 breast samples from 2 groups of participants as a demonstration of system performance when using thermodesorption on the Sentry instrument, like you can see in the photo, coupled with GC/GC TOF/MS. And you can see in this zoomed section the extra information that you can get from the enhanced separation by GC/GC. And because we've physically separated these peaks, we can get cleaner spectra for more confident identification. And the structured ordering of GC/GC chromatograms can also help to identify these compounds. We can then import all of the raw data into Chrome Compare Plus, and over 1 million individual features were found. But using the feature discovery tool, we can narrow this down to the top 100 most significant differences, as we can see here, which shows the 2 groups clustering separately in the PCA score plot. Or we can use other visualization tools like volcano plots to investigate these, where the statistical significance of the differences between classes for each feature is plotted against the magnitude of this difference. So that ensures that small yet significant differences are not missed. And we can see one here that shows high significance, and this was actually also selected as the most important feature using feature discovery. And now that we've found this difference, we can then go back to the chromatograms to identify the feature. And it was found to be in higher levels in the group B samples compared to group A, as you can see in the box plots. And zooming in on the section of the chromatograms for an example from group A and group B, you can clearly see there's a difference that was identified as dimethyl disulfide. So this untargeted approach has allowed you to quickly find the differences between classes so that you can identify these, instead of wasting time identifying hundreds of different peaks that might not be significant. Looking at the other features highlighted as key differentiators, we find that there is actually a number of sulfur compounds that were found at increased levels in the group B samples. And in fact, group B samples were taken from participants after lunch. So it's not surprising to see the presence of these, as they may have come from the food and drink consumed. But it does show how Chrome Compare Plus can find trace differences in an untargeted manner that can equally be applied to changes resulting from metabolic differences in full biomarker discovery studies. Hopefully this presentation has shown that in untargeted discovery workflows, every stage must be optimized to extract maximum analytical information from the samples. And while sampling, separation, and detection are important, they are just the beginning. Untargeted data analysis is also needed to find the differences that you didn't know to look for. And with Chrome Compare Plus, we've shown that you can tackle this challenge by transforming complex 1D and 2D GCMS chromatograms into meaningful results. And together, this provides an end-to-end untargeted workflow for biomarker discovery. That brings me to the end of this presentation. Thank you again for tuning in. If you have any questions about what you've seen or would like further information or to request a software demo, please don't hesitate to get in touch. Stay safe and well. Goodbye.
Fantastic. Thank you very much, Laura. How are you doing?
Good, thank
Can you hear me?
Yes,
Fantastic.
I can hear you.
I can hear you. Fantastic. Thanks so much for that. So a few questions have come through. One is, how effective is the dry purging for water removal, and what else is removed? So I suppose one of the concerns may be, are VOCs of interest removed as well?
So the dry purging, it can be applied to remove the water, and you can choose sorbents too for the trap and for the tubes that will not retain water. So you can optimize all of the parameters and instrument choices basically to ensure that you're not going to get that impact of water going through into the GCMS.
Okay. One related to the retention time alignment. So for the workflow for this alignment, do you need to select reference peaks?
So with the alignment, we simply select the chromatogram that you want to align all of the others in the batch to, and you can run that as a method in a sequence. So with the alignment, it is for GCMS data, I should note, because it does rely on using the spectral information. So with your samples, you can't have wildly different sample types. There needs to be a few peaks in common between these. So having a batch of breath samples, you're going to have multiple peaks in common, and the alignment will run efficiently. But with completely different sample types, it may struggle because you won't have enough peaks in common to help the alignment algorithm. But it really is essential to run that alignment before using the raw data approach when you're looking at absolutely everything in the chromatograms, just because if you don't have well-aligned data, then you've got that risk of getting false positives and any error added onto your data analysis.
That makes sense. So the types of things that we know are definitively on all breath compounds, acetone, isoprene, those types of things. Is that what?
Exactly.
A question here from Maddie. Can you normalize the data in this software, or would you need to export to another statistics platform?
Yeah, so within the Chrome Compare Plus software, you can do normalization. So we've included features like grand total or sum normalization, as well as probable quotient normalization, which is used quite frequently in metabolomics studies now, and the traditional internal standard normalization as well. And there's extra transformation tools that you can use, like square root and log 10. So we've tried to include on a range of different options there. But if there are particular normalization techniques that you use already, you can actually export all of the data out as CSV. So it means that if you're already using other stats packages, it can be exported as one CSV file, and then you could use any of those tools that you've already developed.
Question from Kaylee. Which file formats can Chrome Compare Plus be used with?
So it works with a range of different files for both 1D and 2D data, like you saw in the presentation, and it can be used for a range of different GCMS vendors, from .d adjuvant files, .raw thermal, for LICO or CDF files that then work with quite a range of other GCMS systems. So it is able to cope with quite a wide variety there. And even though the alignment won't work for the single channel data, currently it's for the GCMS only, like I said, you can still use the chemometrics part for single channel data like FID, for example.
Time for one more quick one. How much enrichment do you typically get from the electrically cooled focusing trap?
So that will depend on the technique that you're using. With the Sentry system, where the enrichment was mentioned, for headspace injections for SPME, for example, you can actually do multiple sampling, and then inject onto the same trap. So you're enriching that way. So you could do threefold enrichment in that case before sending the sample to the GCMS. So in that case, you're really improving the detection limits.
Thanks so much.
Thank you very much.